We have made it. We are finally there. I'm trying to contain my excitement anyhow. We are on the very last lesson, the last video of the entire year to go with our textbook. Module 13, Lesson 7, Indirect Measurements. According to the textbook, we're going to have a single day lesson here. There is only 10 resources. Fingers crossed, we might get this done in one video. Let's get started. They didn't even waste our time with any foo-foo stuff. We're getting straight into the inquiry question that says, how can you find the lengths that are difficult to measure directly? And the answer to that is through indirect measurements. The sketch represents what might happen on a sunny day. Two objects, you and a tree, and their shadows form the sides of a right triangle. The sun is so far away and large that its rays are essentially parallel to each when they reach the earth. So now we're going to take a look at the image here. You can see the blue, that's going to be your shadow. The green, that's going to be the blue's you, the green's the tree, and the black on each, that's going to be the shadows that go with those. What objects in the sketch can you easily measure in real life? Well, you can easily measure your height, you can measure your shadow, and you can measure the tree shadow. You cannot, however, easily measure the height of the tree. In the sketch, you can, how can you show triangle ABC and triangle DEF are similar? That would be doing those corresponding side things. And then from there is, if the triangles are similar, what do you know about the lengths of their sides? Let's keep going here. The next question asks, what happens when we drag points A, B, and D up, down, or side to side? Be careful not to drag the points below the line that represent the ground. All right, so if I take and drag up A, you can see that the shadow of that tree is going to get long, or your shadow is going to get longer. If you grow, if you suddenly shrink, your shadow is going to get shorter. Same with the tree. As the tree grows, its shadow gets longer. As a tree shrinks, the shadow gets shorter. Next, what happens when you press the animate button? Record your observation. So I'm going to scroll down and press the animate button, and now what's going on there? The sun is moving, and as the sun moves, the shadow changes. The height of you, the height of the tree stays the same, but the length of the shadow that you put off and the length of the tree, the shadow that the tree puts off, are going to change. Despite that, they're all going to stay similar. From here, we're going to take and say drag and drop the point of the segment that represents you until the length corresponds to your height, and then drag the tree to the height, a height taller than you. Adjust the sun's rays to a different angle. Watch the measurements change. All right, so I am 6'1", so we're going to call that me as being 6'1", so we're going to call that right about there, 6.17 feet. That's close enough for me. My shadow will be 1.6. Now we're going to take that tree and we're going to make that tree grow, and as the tree's height grows, the shadow grows. And from there, it also said what happens when you change the angle of the sun. Well, when you change the angle of the sun, those shadows are going to move together. When that sun's straight up, there's no shadow at all. When the sun goes the other direction, the shadows go the other direction. Easy math. Anything else worthwhile we want to look at here? Nope. I think that's enough exploring around. Let's get busy learning. And it turns out we do have a foo-foo intro. They just saved it for later. Have you ever looked down the road at your shadow and the shadow of a person next to you were different lengths? This is because the length of your shadow is proportional to the length of your height. So unless you and the person next to you are the exact same height, your shadows are going to be different lengths. Suppose Marita is 5 feet tall and casts a shadow that's 7.5 feet long, pretty late in the day there. At the same time, Jacob casts a shadow that is 9 feet long. How can you use the properties of similar right triangles to find Jacob's height? This is what we're going to learn to do in this lesson. Learning indirect measures is the next thing we have up. It's loading. There we go. An indirect measure allows you to use properties of similar polygons to find the distances or lengths that are difficult to measure directly, like the height of that tree. One type of indirect measurement is shadow reckoning. Two objects and their shadows form two sides of a right triangle. In shadow problems, you can assume that the angles formed by the sun's rays and the two objects at the same location are going to be congruent. Since the two pairs of corresponding angles are congruent, the two right triangles will be similar. Let's keep going. Skipping today's standards, example number 1 next. The lead scout statue of the Korean War Memorial in Washington, D.C. cast a 43.5-inch shadow. If you've never seen that, you should really stop. It's worth stopping to see. At the same time, a nearby tourist cast a shadow that is 32 inches long. If the tourist is 64 inches tall, how tall is the how tall is the statue going to be? What are the corresponding sides of the right triangles? Well, the height of the statue and the height of the person are going to be the corresponding sides. The shadow of the statue compared to the shadow of the person, that's going to be your other corresponding sides. From here, we can say that the tourist height was 64 inches compared to the tourist shadow of 32 inches. So you ask yourself, 32 times what is 64? And that is going to end up being 2 that you see there. Because we multiply 64 by 2, we also need to multiply the shadow of the statue by 2, which is going to be, let's see, that's 87 inches is what's going to go right there. Check it. And now we know that the statue is 87 inches tall. That is one example of how you can do indirect measurements. I'm telling you, they're squirrely on how they built this. Because what comes next? Vocabulary you're going to learn. We're going to skip that, and there's your extra example. Somebody else was in a big hurry to finish this lesson too, I think, and they didn't put it all together right. At the same time, a 2-meter street sign casts a 3-meter shadow. A nearby pole casts an 18.6-meter shadow. How tall is the pole? Go ahead, pause the video, figure that one out on your own. I'm going to start off by doing just a drawing, okay? My drawing is going to be a sign right here, so we'll call it a stop sign or whatever, and we know it is 2 meters tall and it has a 3-meter shadow. This is compared to a pole, and the pole we don't know how tall it is, but we do know that its shadow is 18.6. Now the ratio I'm going to set up is going to be to compare my height of my sign to the height of the shadow is equal to the height of the pole to the or actually length of the shadow to the length of the pole shadow. Now, from there, I'm going to have to do some math. I'm going to say that 3 times what number is equal to 18.6. We're going to have to do a little division to find that out because actually the answer is going to end up being 6.2. But I'm going to show you how I got that. I'm going to take 18.6, divide it by 3. 3 goes into 18 6 times. 6 times 3 is 18. Decimal goes up, 6 goes down, 3 goes into 6 2 times, which is 6, nothing left over. So 3 times 6.2 is 18. That means the height of the tree is going to be, the height of the pole is going to be 2 times that same 6.2, which means the pole itself is going to end up being 12.4 tall. So I'm going to come back over here, and I could also take right here now and say that x is going to equal to 12.4, and that was meters. We'll jump back over to the textbook right here. We're going to put in our 12.4 meters, check it, and it checks. Easy math. For example 2, we can say that figure triangle DBA, which is the little one here, DBA, is similar to triangle ECA, which is going to be the big triangle. Find the distance D across the lake. So we want to know the distance between point C and point E. We have the side AB, we have side BD, and we can figure out side AC. So let's move forward with this and see how we're going to work this problem. First, it tells us to drag triangle ABD into the box below. So I'm going to grab ABD, I'm going to put it into the box below. Alright, I've done that. So I've now separated my two triangles. Now we can set up a proportion to find the missing measure. So I can say that AB right here is going to be similar to or corresponding to AC, that long length. And then I can say that that would end up being the 320 for AB over 482. The 482 came from adding 320 and 162. So 320 over 482 is equal to, well, this height here we know is 40, and side CA, also known as D, that's what we're looking for. So it is equal to 40 over D. Now they took and said, well, 320 divided by 40 is 8, also known as saying 320 divided by 8 is equal to 40. So now we have to take the 482 and divide it by 40, and I'm so happy that we're almost done. I'm going to do it with a calculator. Divide by the 8 right here, and that's going to give us a length of 60.25. So the length across that lake is going to be 60.25 meters. And we're going to take and check that. And it checks. That's all there was to doing it. You got to find your corresponding sides, set up your ratios, your proportions, find the missing side length. That's going to be it for that one. We have one more extra example. This is the last one in the textbook for the entire year. Do this on your own. How did it go? Did you get your last extra practice problem right? Let's find out. In figure, triangle TXZ is similar to triangle WYZ. Find the distance D from the house to the street. Okay, so let's take and actually get in here and figure out what we're looking at. We are looking to find the distance D from the house to the street light. So we're going to start over here, and this distance here is what we're going, nope, not quite. This distance here from the house, come on baby, work for me. From the house to the street light, that's what we're looking for. That is going to be side XZ. That would correspond to this side right here, which is going to be side ZY or YZ. From here, I'm sorry, yep, that's right. Next, I can take and say that that is going to be equal to what? Well, I can say that over here, I've got side XT would then correspond to this outside thing here, WY. And now I'm going to put in what I know. I know that XZ is what I'm looking for, that side length D, and I know that this side right here, XT, that is going to equal to 8. Furthermore, I know that side ZY is going to equal to 5. That's going to be this distance right here. And I know that side WY, that's going to end up being 4, which means that now I don't have something that works really, really nice. But we're going to make it work. I'm going to say there's other ways I could have set this up that would have gone better, but that's okay. So, first question is, 4 times what is equal to 5? And that answer, that's going to be 1.25. Okay, I'm not going to grind it out. Grab a calculator if you want, do it on paper. I don't care at this point. I should not, however, have put that 1.5 there. Let me erase that. And that 1.5 is going to go right here, 1.25. So now, if 4 times 1.25 is 8, I'm sorry, it's 5, then I can say 8 times 1.25. That's going to be our missing side length D. The answer to that is going to be 10. So I can now say that D is equal to 10. Circle that answer. I'm going to jump right back over here to my textbook. I'm going to answer the last question of the year. 10, check the answer. Hoorah! We are done. Now let me share something with y'all. I started making these videos the first week or so of school. I think the second week of school we finally got the textbook. Today is January 21st. Over the course of that time, I've made 106 6th grade math videos. I've made 105 regular 7th grade math videos, and I made 118 advanced math videos for 7th grade. That is 329 videos I have made since the start of school. And this, boys and girls, is where it ends. Y'all have a great night. Get started on your homework. Bring me any questions you have in class tomorrow.